Very good afternoon, students. I am Dr. Sumayya Inamdar. Today we start the second semester of BSc Part 1. For this semester, I will teach you the chapter Vector Analysis. In this chapter, we learn about the scalar quantities, vector quantities that you have already learned in 11th standard or maybe in a 12th standard. And after that, we learn about the gradient, then divergence, curl, Gauss theorems and Stokes theorems and Green's theorem. This is very important chapter. So we start with the scalar quantities and vector quantities. Suppose we have any physical quantity that is divided into two quantities. All the physical quantities are all physical quantities that are divided into two, that is either physical quantity is a scalar quantity or it is a vector quantity. What is the difference between them? The scalar quantity to specify or to define the scalar physical quantity, we require only the magnitude of that physical quantity and its unit. It is sufficient to define the scalar quantity. For example, suppose we have to measure the weight of the 1 kilogram of the sugar. Then it is sufficient the magnitude means suppose 1 kg, that is magnitude, and 1 kg is unit. This sufficient means 1 kilogram of sugar. It's sufficient to define the weight of the sugar. But suppose the physical quantity is a vector quantity. The vector quantity, to define any vector quantity, it is necessary to define its magnitude as well as its direction. For example, we have to measure the velocity of the earth or velocity of the vehicle. At that time, we have to the knowledge about its direction and the magnitude. Okay, this is the vector quantities and the scalar quantity. So we start with the scalar quantities and scalar dot product. Start with the scalar product, or it is a dot product. Suppose these are the two vectors. This is the vector A bar and this is vector B bar, and this vector A bar and B bar makes an angle theta. Okay, now how to define the scalar product or dot product? How we define the scalar product? The scalar product or the dot product is defined as the A bar B bar is equal to the product of magnitude of two vectors into cosine of angle between them. The dot product of two vectors is defined as the product of their magnitude into cosine of angle between them. This is the scalar product, or we can say that it is the dot product. Okay, now we see the characteristics of the scalar product. Characteristics of dot product or scalar product. Okay. The first property of the scalar product is the scalar product obeys commutative law. Scalar product obeys the commutative law. What is a commutative law? See, suppose A bar and B bar are the